We are now in the position to start writing the code for the carpet area problem. So let me just define a function called, say, max area. To this, there's an argument called the list, the list of lengths. So let's just say find the maximum carpet area bounded by items of L. So that's what we're trying to do. Remember, as before, I set the two pointers, JJ to 0, KK to len of L minus 1. So the two extremes. I just set the area to 100 because I know that area is going to be positive number. The first time I compute a new area, I want it to be, updated. So that's why I just set it to a negative number. And I do this while JJ is less than KK. So while JJ is less than KK, basically, while my left pointer is still not equal to the right pointer because the two are moving inside. So strictly, I compute the area between JJ and KK. I denote that by this variable AJJKK. Remember, the area is given by minimum of L JJ L KK and multiplied by KK minus JJ. Remember, as we discussed, KK is, by the way the problem is set up, KK is more than JJ, so I do not need the absolute value here. Now I ask myself a question, if AJJKK is more than the area, remember the first time round I've set to negative, so it has to be, I will update the area to be AJJKK. And I'll also keep track of what are these indices because potentially this could be the maximum indices. So I just go and say, well, JJKK max, and I use a tuple here to say JJKK so that I can return this later on. Now, if I find that L, so notice I have updated the area if needed. Then I ask myself, which pointer do I move? So the logic is very simple. If LJJ is less than or equal to LKK, notice we look at the lengths of those two lines pointed by the pointers JJ and KK. If LJJ is less than or equal to LKK, well, I am going to move my, the left pointer inwards. So JJ is equal to JJ plus 1 or JJ is plus equal to 1. Else, if I, find that reverse situation, basically LJJ is greater than LKK, or in other words, LKK is less than LJJ. It means that I will move my right pointer to the left. So KK, I can say is, so let's just be consistent. So KK minus 1. Of course, I can write this also as KK minus equals to 1. And once this happens, once the loop runs, I can go and return the area and let's say JJKK max, right? So very interesting, how the two-pointer approach. So now that the function is done, I can define a list. Let's say, 1, 12, say 1, 12, 3, 7, 2, any list is fine. These are the list of the lengths. Now, clearly, this need not be sorted. So I'm just taking as an example, let's say 12, 3, 8, 9, 19, 2, 1, and say 4, just as in, like I said, just as illustration. I go and find out A is, let's say, max area, L is my argument. So this list of the lengths of the lines. Then I can go and print, for example, A0 and A1. When I run this, I get my, let's see if this runs correctly. Yes, I get 96 as the answer, 1 and 9. So basically what it's telling me is that, look, two tall lines, 12 and 19 dominate. This is at 1 and 9, so 12 times 8 is 96. Let's trust this algorithm. In fact, actually, so there's also 12 and 9, but these two are closer to each other, so the area will be lesser, remember? So it's bounded by the shorter of the two. So we want these tall lines to be far away from each other, and indeed, that's what I see. Let's just say if I had, let's say maybe over here, if I made it 14, perhaps this will change. In fact, it does change. So now it's 1 and 12, right? So you can play with this, um, you know, uh, quite nice. We can even plot this because plotting creates visualization. So, for example, here what's going on is, between those numbers that I took, so 12 and 19 was the tallest, and this was indeed the biggest carpet that I can put. Now think about it. Why is this bringing efficiency? Well, because, in the process of moving these pointers smartly, as we discussed, we are eliminating many choices that were totally redundant, that would clearly not lead to an increased surface area. Exactly the same idea, exactly the same, let's say, intuition logic that we used for the pair sum problem. We moved only in the direction where the sum would potentially go closer to the to the target that we had. There, the list being sorted helped. Here it doesn't matter. We have found a metric and we have found a way to move that metric in the right direction, and hence the list doesn't need to be sorted also, right? So, but the complexity has come down to being a linear complexity. Think about it. Very interesting. Happy to discuss. Do look at our website www.ybyte.in. We have a lot of material for new programmers to learn Python, programming, logic, and algorithms in a fun way. Forever enjoy coding. Take care. Thank you so much. Bye bye.